I'm now pleased to welcome this afternoon's speaker, Dr. Vitor Favoretto. Dr. Vitor remains deeply rooted in the family farm in Brazil. Soybeans were always in the spotlight during his undergraduate studies at Londrina State University in Parana State, Brazil. After a quick experience with small grains at Kansas State University, he returned to soybeans to pursue his master's and doctoral degrees at the University of Illinois here in Urbana-Champaign, researching management practices for high yield and high protein soybean. He thinks his 7+ years of experience with soybean in Brazil and the US did not prepare him enough for the challenge he faces as the disease and pest team coordinator at the Soybean Innovation Laboratory currently. However, he is eager to learn and use his experience to help African farmers achieve soybean success by avoiding yield losses and helping the laboratory on the mission to achieve the sustainability of the soybean value chain in Africa. So today, Vitor will explain how the one-size-fits-all use of biological products may not be the perfect fit for your fields. Embark with him in this 40-minute journey to understand the different types of biologicals, what they do in the plant, and how you can tailor technology for higher quality and yields. So with that, let's welcome Dr. Favoretto.
Yeah, everybody hear me okay? I don't usually use microphones, but for the folks online, I'm going to use that. So thank you, Jennifer, for the amazing introduction. I am Dr. Vitor Favoretto. Good afternoon, everybody on the audience. I'm thrilled to be here in the Illinois Soybean Summit in 2023 to talk about biologicals on soybeans and how we need to not be blind and be bright to achieve success with that technology. And Jennifer spilled a little bit of the beans there in the introduction, but the first question that you guys probably have in mind is, who the hell is this guy speaking in front of you with this heavy Southern accent, right? Well, I actually come from Brazil, and I brought here a picture that depicts the family farm there. We have some corn, some wheat, and some oats in there. Unfortunately, in the time we didn't have soybeans. But not only having my family farm on the background there, where I got my passion for agriculture, but we have the 3 people responsible for putting me into agronomy in the first place. You have my dad there in blue, you have my grandpa in the middle, and then you have my uncle in orange, which completes the Illinois colors, by the way, so that was that. Who takes care of the family farm now, or since my grandpa passed away. And a little bit about my background. I did my undergrad in Londrina, as Jennifer said, there in southern Brazil. Grew my passions on soybeans there, and decided to come here and work with Dr. Bilos's group in the middle of the Corn Belt. And despite what that picture might tell you, I came in here to be the soybean guy of the lab. And my passions for soybeans were just too much that after my graduation with my PhD last year, I started working with the Soybean Innovation Lab, where I was starting to do soybean production in Africa. But this is a talk for another moment or another talk. Today, I'm here to basically wear my crop physiology lab hat and remember my time with Dr. Bilo. This is a picture we were in a soybean congress back in Brazil, back in 2018. And as a Bilo student, it's basically unavoidable that I need to talk about this publication, or the 6 Secrets of Soybean Success, the trademark of Dr. Bilo. You probably heard him present on it. I presented on it a couple times. And all the soybean research we've done was based on the 6 secrets. But today, as the theme of my presentation, I'm going to talk about the secret that Dr. Bilo missed, the 7th secret of soybean success, or biological soybeans. So this 7th soybean secret that to increase yields and quality of soybeans are technically called biostimulants, but I think biologicals is a way cooler name, so I'm going to use that for the remaining of the presentation. And well, we're in a science breakout, so I brought a science definition from a textbook of soybeans about what is biological. They define as a recent management strategy that, when well used, it can increase tolerance to weather, maximize efficiency of the resources, and build higher yields for soybeans. And that's a great definition, very textbook, but it doesn't answer the question in the room or the practical question of what are biologicals? What are all those products that we have in the market right now? And how can we use those in our soybean operation? Well, luckily, I'm here to try and help figure out that with you guys. And to start unraveling the mystery of biologicals on soybeans, I'm actually going to subdivide them in subcategories. And I'm going to steal some of the work from my former colleagues, Dr. Connor Siebel and Logan Woodward from the crop physiology lab, who actually published a paper in this, so it's well defined there. And when we're talking biologicals, even though they are all biologicals, we can subdivide them in 8 different categories. We have different names, so we cannot assume that they are all the same. And each subcategory does something on the plant. And we need to know what each product does before we can apply them in our soybeans. You know, like if you're having a difficult time, try to link the subcategories as football teams. Despite what my wife says, and she says all football teams are the same, you and I know that each football team is unique and does something on it's unique, and we cannot compare each one of them or assume all football teams are the same. So the message is that on biologicals, there is not a unique size, or one product won't do it all. And we need to know exactly what each subcategory does in the plant, so we can have success with that technology on soybeans. So I'll start with the easiest one, which is nitrogen fixing bacteria, which would increase the availability of nitrogen in your operation there for plants. Then you have the mycorrhizal. I was practicing to say that word right. I got it. Mycorrhizal fungi, who extends the root system of the plant. So it's not technically giving nutrients to the plants, but it's giving the plant more ability to mine nutrients from the soil. We have the P-solubilizing microbes, which the name says it all. It works on the availability of mineral P. So if you fertilize your soybeans, we learned that TSP was a better source from Andrew Marginot there. You may want to experiment with that kind of biologicals to maximize the efficiency of the mineral phosphorus you're putting on your soybeans. A residue degradation category there. This is a newly addition from Dr. Connor Siebel. There are some biologicals and some substances there that helps degrade the crop residue that you have from the previous crop. So by breaking that residue, you're making an array of nutrients available for your planted crop right now. We have enzymes, phosphatases, which increase the availability of organic phosphorus. So different from the P-solubilizing microbes, the phosphatases work on the organic matter of your soil, making the phosphorus available from the organic matter. So if you have less organic matter in your soils, maybe phosphatases are not the right strategy for you there. Next, we have the humic and pubic acids, and they do fancy things. Scientifically, we say that they chelate soil cations and feed microbes. Well, they work in positively charged nutrients like potassium, some micronutrients, and ammonium, and it prevents those nutrients from getting fixed to the soil and more available to plants. And since they are organic acids formed of carbon, they can be food source for the microbes that you already have in your soil there. So having that in mind, you can probably know if that's right for your soybean operation. And lastly, I've been trying to preach here that biologicals are different. Everybody does different things, and we cannot generalize them. But those two categories are tricky because, well, they do the same thing. They stimulate the microbes and the roots of plants there to maximize growth. But I know how to differentiate them. Well, if you think of marine extracts, they came from plants, they came from algae. Well, sugars are also plant extracts in a way, but you cannot use marine extracts to make your crappy coffee taste better, right? So that's how you differentiate that category there. And this was a heavy slide. I probably spent 5 minutes in it. But the message here is we need to know what each biological product does within where each biological fit in these categories, and couple that information with, as a farmer, what do you need in your soybean operation to maximize the success of biologicals in soybeans? And actually, that's the Homer message that I have today, is that we need to know that each biological is unique and couple the information on knowing how the biological works. So seek help from the extension folks, seek help from university, seek help even from people like Pest hybrids that do that PFR thing to know what that biological product does, and couple that information to your soybean needs. And that's the key for success of biological soybeans. And I could end my presentation here, I would be short 20 minutes or so, but last time we checked the program, this section is all about science, right? And since I highlighted science there and the sponsorship, I wanted to thank Bacter again to sponsor this blitz. And since it's science, well, what does the data tells us about biologicals and soybeans? So I'm here to summarize in 20 minutes or so, 6 years of data. You see that I cheated a little bit. It's actually 5 years, but I'm counting 2023 as well. That we've spent in the crop physiology, like looking through biologicals and soybeans within 5 locations in Illinois, which sums up to be roughly 900 research plots so far. So the first low-hanging fruit of biologicals and soybeans are the nitrogen-fixing bacteria, because soybeans, when you pull those roots out of your fields, you have those little balls in them, and those balls are actually called nodules, which are actual bacteria that soybeans partners with to fix nitrogen from air and give that nitrogen for soybeans. And roughly here, we're talking Illinois and the United States, soybean with the fixation that comes from the soil, we don't need to apply anything. Those bacteria can provide a little bit more than half of the nitrogen need for soybeans only by the partnership that they have. But, that figure doesn't sound right, and we probably can maximize. And I have a question for you all. How much can we have as a percentage of the nitrogen coming from the nodules? And I'm going to give you a hint, it's more than half. Does anybody want to take a guess? All of it, 75%. Do we have any other guesses? It's more than 75, but not all. Okay. So in the interest of time, Nefsinger, I want to give you this prize for your participation there. You were pretty close. It's actually 94 in the exact figure there. And since we're talking science, I put the almost 20-year-old papers where I got this from. But we have the potential to enhance nitrogen fixation on soybeans there and make that be the solely provider of nitrogen to soybeans. So instead of relying on mineral or only the soil, we can maximize them. And as an avid master's student, when I started in 2018, I was shocked to see that growers here in Illinois didn't inoculate their soybeans year after year, like we do in Brazil. So I did a small experiment in 2018 and 2019, looking at traditional ways to enhance nitrogen-fixing bacteria using traditional, or the first biologicals on soybean inoculants using Bradyrhizobium japonicum. And I used to do the most traditional way of applying them, which is through seed treatment. And with that little experiment, I wanted to answer the question, how effective is inoculating the seed with the known bacteria that fixes nitrogen for soybeans here in Illinois? Well, for the older folks in the audience, you probably already know the answer for that question. But as an avid master's student, I put together a project over 2 years in 2018 and 2019. And I used 3 diverse locations in Illinois. And as we can see in the map there that I kindly put in Brazilian colors, Illinois is the long state from north to south that depicts 3 different regions or 3 different levels of soil fertility, with the soils in the north part of the state being more fertile, having higher values on the soil test. Southern Illinois having the lower soil fertility levels, and central Illinois being there in between. So by using those 3 locations, I wanted to capture these 3 environments there. And of course, not all soybean varieties are the same. So in the first year, I used 2 different soybean varieties, and everything went beautifully with planting dates. 2019 was a rough year, I think, for everybody. Everybody remembers it. So we needed to downsize to only 1 variety and plant that trial late. And since I was testing seed inoculation, sorry for not using microphone, but I used Precise CL, which is a commercially available product here in the US. And, here are the results I've got. So we can see the 3 locations and the 3 distinct yield environments, which are reflective of not only the soil test values, but the weather there. It's not an exact science, but you get the feeling there. And I was eager to see the results. And to show you the results today, I want to use this, which I call my Christmas light color schemes. I'm putting the responses relative to the control, and when the number is red, the response is negative, and when the number is green, the response is positive. And unfortunately, we don't see much green in that table. So, I was a master's student, I was pretty bummed on these results. But in 2021, I tackled this question again, because then I was reading scientific literature and comparing the numbers of how much nitrogen comes from the nodules in the US and Brazil. I see that Brazil has a higher percentage of the nitrogen coming from the nodules. So don't ask many questions, but we brought in a Brazilian inoculant to test this and tackle the question, are Brazilian bacterial strains of Rhyzobium japonicum more effective in improving soybean yield? Unfortunately, the results were similar in Illinois. I tried trying over the results to see if they would change the numbers there, but that didn't work. So the main point is traditional inoculation, at least here in Illinois, they lack of consistency in positive yield responses. I was pretty bummed to come to that conclusion. And, I went to the soybean field, actually. We started drinking some bottles of science with that soybean field. And for the 5th or 6th bottle of science I was drinking, the soybean started to talk back to me. And we were discussing, are there other strategies for soybean biologicals? And as the discussion went on, we started to think about maybe not only seed inoculation, but maybe put that in furrow, or spray that foliarly on soybeans. And why stay only with the traditional inoculant? Why not seek for other nitrogen-fixing bacteria that were not meant for soybeans? So we went off-label on those, but explore other categories of soybean biologicals like pea-solubilizing microbes and marine extracts, not sugars. You cannot put that in your coffee. So after the bottles of science effect Pest, we went back to the drawing board and thought of new strategies for biological soybeans. So we tackled this problem with 2 sets of experiments. The first one we did in 2020 and 2021, where we used 3 diverse locations in Illinois, as I already explained to you, but now we know that the yield potential of these three different regions are different. I only used one variety. I needed to give some space there to other trials, but I used a more recent variety, an extent flex variety. I used a 3.5 maturity group because I wanted to have the same variety across all locations. And I didn't stay only on Rhizobium japonicum as biologicals for soybeans, since products started flowing to market. So we tested other nitrogen fixers, other nutrient solubilizers, and even some marine extracts in here. And well, seed treatment didn't work in the first 2 years, so I explored other application methods as well. And we did all these biologicals in a standard management system where soybeans were 30 inches apart and nothing else but the biologicals were applied to them during the season. And with this set of trials, we were able to tackle one overarching question, which is where and when biologicals work better for soybeans. Not only, geographically, but are biologicals for every soybean operation, higher yield, lower yield, and where and when do we place biologicals in the soybean crop? So here I bring all the things we tested. In the first column there, we have the application methods. And for each application method, we have 3 different products. And as the table goes on, we'll have the grain yield by Illinois region there. But the first application method, I needed to have the traditional seed treatment for comparison. But this time, I brought in the Brazilian inoculant there. Responses weren't good, they were more positive than the other inoculants. And then I used that Brazilian inoculant, and I put another funky name out there, which is a practice called co-inoculation, scientific for put 2 microbes together in seed. I used Azospirillum brasiliensis, another nitrogen-fixing bacteria. But then I started to get a little bit crazy with this product, Logfix Duo. It's a different species of Rhizobium, and it's not coupled with another nitrogen fixer, but coupled with the Ophiuchus pseudovorans. I needed to memorize all these difficult names. It's a bacteria that solubilizes sulfur, so I'm providing nitrogen and sulfur to those soybeans. And from there down, things get crazier and crazier. So now we're talking about in-furrow placement of biologicals. I know in-furrow operations on soybeans are not very big in Illinois, but it's growing rapidly. But the rationale here is probably not put the biological on the seed to compete with that fungicide treatment, but still with the seed in that band there. And the first product I used was Invita. Well, you're probably familiar with Invita or not, but it's a nitrogen-fixing bacteria from sugarcane labeled for corn in the US. I went a little bit off labeling that. And to keep the off-label theme going, I put Invigorate, which has some nitrogen-fixing bacteria and some phosphorus solubilizing microbes as well, and finished with Proven. Yeah, that product for corn and sorghum, I put that on soybeans, which is an engineered bacteria that never stops fixing nitrogen. And lastly, it's more common for growers to spray herbicides in their soybean operations around V4. So if a grower is already used to spraying soybeans at V4, maybe we can use that time to spray some biologicals. And I still use the Invita product because on their website, they claimed they had foliar activity. I was eager to test that. I use Grep ST Pro, which is a marine extract coupled with cobalt molybdenum. So a little bit of micronutrient action as well. And then we have Source. And I put them last because they don't define themselves as biological. If you go to the news articles. But it is a substance, and I would classify them as sugars because it's maltol, but you cannot put that in your coffee. So I'm not kind of in defense there. but they stimulate nitrogen fixers and phosphorus solubilizing microbes there to provide more of those nutrients to your plants. So I was eager to test that. And the first result we got from this set of experiment is something that is rare, but it happens. Actually, Southern Illinois was the highest yielding site. I'll blame this on the weather. Learned that from Dr. Bilo, by the way. But when we look at the biological responses to soybean, we don't see much green there. But there is still something to learn from this data. The first thing is most of the green is in Southern Illinois or the highest yielding site. So maybe there's an indication there that biologicals work better in higher yielding sites as a supplement to higher yielding soybeans. And the second thing that tended in this data is not statistically significant, but in practical terms, it would work 70% of the time. Some of the products have positive responses there. I highlighted one product there, but I won't say any names. But the important thing is the responses came more frequently from placements that were beyond seed treatment. So within furrow placement or even foliarly, we have that some of that activity we were talking about. And just to clarify something I didn't say earlier, the V4 application targets the leaves of soybean, but targets the soil as well, since the canopy didn't close yet. So the biggest conclusion of this big trial is not as strong, but gave us some indication that yield increases, or soybean yield increases with the biological applications are more likely in higher yielding environments with placements that go beyond the seed treatment, showing some more promise there. Well, and with those conclusions in mind, people from the crop physiology lab, actually Dr. Connor Sibo, carried on testing biologicals on soybeans, and we entered the second set of experiments that were conducted in 2022 and are going to be conducted this year as well. And they needed to, focus only on Champaign, and that's because I was out there. They were out of the best worker, so they needed to focus the efforts on Champaign there. But they carried on the beyond seed treatment concept, testing different application methods. They went back on testing diverse varieties to see biologicals for every soybean varieties out there. And they test more categories of biological than I did back on the day there. I'm not going to touch on all of them because I don't think I have much time, but you can find the complete report of this experiment in their website. It's available online, and I can probably share the PDF with you if you want. But the key thing for this experiment is, even though they didn't have the different locations or the different yielding environments, they changed their management systems to reflect, for me, kind of lower yield scenario or a standard yield scenario and a progress of or higher yielding scenario. In the standard management system, soybeans would just be planted, receive the biologicals, and that'll be it for the season. In the progressive system, they would apply some pre-plant fertility, which included sulfur, by the way, another work of mine. That's another talk. Talked with the Illinois Association folks to invite me next year to talk about sulfur on soybeans. But they put some pre-plant nutrition with sulfur coupled with a little bit of nitrogen there using ammonium sulfate. And they put a foliar protection package at R3 as the progressive system, which I like to call the higher yielding system. And with the set of experiments for the purpose of this presentation, we can tackle the questions, hone in the questions, are biologicals for a progressive or a higher yield growth system, or for the standard grower out there? More refined question than the ones that I had, are biologicals for everybody or not? And also try to focus, because it wasn't clear in my data there, where do we place biologicals on soybeans? Where is the optimum placement of biologicals on soybeans? So after all this explanation, here is the data, and I steal the slides from Connor. He gracefully gave them to me. We have this table where we have 4 different products from the 8 we tested. And those products, although we have some citric in here, they are mostly foliar products. So that foliar placement and going even beyond the V4, V5 stage to that later foliar protection package. And we're going to have the results for each variety and then divided by each management system there. And when we look at the Christmas light color scheme, we see a lot more green than the others experiments we have there with this product. And if we start being a little bit more scientific and divided by management systems, we see that progressive systems tend to have better responses when applied with biologicals. So that's kind of one of the good takeaways from this study in 2022, that soybean tended to be more positive, or tended to more positive respond to biologicals in a more progressive system, which I like to call higher yielding system, with fertility and foliar protection. So we have that common trend with biologicals in soybeans. So to summarize my presentation, we already know the first key takeaway that every soybean every biological is unique, and we need to couple that with the need for your soybean operations to be successful there. And what the data is showing us so far is that biologicals work better on a higher yielding or a more progressive soybean management system. And lastly, biologicals in soybean is you can see, you saw there the lack of green. It's more of a trial and error. So don't go broad acres in your first year and expect failure. And then when failure comes, call me to understand what happened to your soybeans, because how I like to say, sorry folks online, together we are stronger for soybean success. I always wanted to turn my back into the audience, and I find my way through it. And just before I turn into questions in here, I showed you this picture earlier on. I probably blew time, but you guys are still interested, so I'm going to go on. And these pictures are me in Africa. And me being in Africa is made possible by the Soybean Innovation Lab I'm a part of, and I'm wearing a shirt for today. The Soybean Innovation Lab is a project funded by the USAID, hence the logo there, that's been hosted by the University of Illinois since 2014, and has the mission to bring sustainability to the soybean value chain in Africa, develop that value chain, and make sure that the value chain goes on after that Soybean Innovation Lab is out of this world. And we're proud to say that we have been developing this chain in historically 32 countries since 2014. And of course, this effort, we don't do this alone. We have an array of collaborators there. And we have some blank space there in the bottom that Illinois Soybean Association could fit there. But the question in the room, the white elephant in the room is, why does it matter, not only for the Illinois Soybean Association, but for Illinois soybean growers, decide why it matters to develop soybeans in Africa, right? Well, part of the Soybean Innovation Lab, we are trying to increase production of soybeans there in Africa. So yes, we are teaching them how to grow better soybeans. But on the flip side, we have lots of people working on increasing demand for soybean as well, because they are producing more soybeans. We want them to use those soybeans in country. And, if that everything grows correctly and they have a huge soybean value chain in the future, and Adam, Liz, and I forgot the other person in the panel there, all told everybody that maybe Africa can be a potential importation market from American soybeans. So that's the importance of the project for the Illinois growers. Create a potential market that U.S. can export soybeans to them. And we create this demand by, being multidisciplinary project. So we focus on introducing soybean as a protein source for school children. And I have Annette Dunley here. She works with processor in this. And the beauty of this is not only a potential market for soybean products and maybe soybean meal that we might have a surplus in here, but we are also helping children learn better in schools because they're better nourished. We also work in the agronomics team where I'm a part of, to increase the prosperity of the farmer by increasing profits there. So bringing regional development to Africa, and of course, the whole soybean value chain, they're trying to develop that. The important question here is, what do I do as the disease and pest team coordinator, right? So bringing back that map in there, I do help soybean growers in Africa deal with their disease and pest problems there. So I do import some knowledge from the US and some knowledge I had previously from Brazil. But since we are introducing soybean to new areas that haven't been cultivated with soybean before, we are always in the lookout for new soybean diseases or pests that can attack soybean, understand how can we manage this new pest, and whenever this disease or pest arrives in the US, we would already know how can we deal with this pest. Think of it this way. Didn't you want to know how to raise a child before you had one? That's basically what we are trying to do in the disease and pest team of the Soybean Innovation Lab. And with that bad joke, I just wanted to say that the other thing I do there is I create awesome videos in my LinkedIn and Twitter accounts. The Shots of Science, that's the other logo in my shirt here. And before I open for questions, I just want to say contact me in my email or my social media there. Give a special thanks for Stephanie Porter to inviting me over here. I tried to create entertainment for you guys today, and the Illinois Soybean Association for hosting the event. Backs too in the background for sponsoring, and be sure to scan this slide to get your CCA credits there. With that, if I have time, I'll open for questions.
Yeah, we have time.
And more of a caveat, I'd just like to say that the last time we surveyed processors and something here, I haven't found it something on. Thank you. That only 40% of their soybeans were local. So the other 60% has come from somewhere, and we really have a great opportunity here.
%.
40% local. Over.
So you said that the Brazilian soybeans were,
Where did books online?
No.
They can repeat later.
the Brazilian soybeans had a higher percent of the nitrogen got from nodulation. Did you ever bring any of those varieties over here and plant and then see if that same variety did the same thing here? Is it the variety that's different from Brazil to here and not necessarily the products that are helping nodulization?
Yeah, sure. Great question. And just paraphrasing, Brazil has a higher percentage of nitrogen coming from inoculants. Is that inoculant player a variety? And you're on the money then. There's actually 3 reasons for that to happen. First one, Brazil had a huge effort in the 70s to introduce in the breeding programs inoculation instead of mineral nitrogen. So they were selecting varieties that were responsive to inoculation. The second thing was we used to import inoculants from the US, and they, because of the environment and the varieties and everything, they weren't very effective. So the other huge effort were we isolated bacteria that were in our soils there already. And the third thing is the soils that we have here in Illinois. They're just so rich, and the bacteria that is already present in the soil is a little bit more persistent and it's preferred by the soybean varieties that we have here. So I didn't bring any soybean material because everybody goes through immigration, they ask about if I have soybean seeds. They didn't ask about. But well, I imagine that the varieties here would, because this bacteria persistence in the soil that we have here, this rich organic matter that we have here, and the response would be lower as well.
So you said that biologicals work better in a progressive system or a high yield environment. So what is a progressive system? And then also I asked you, what was the yield environment different in Southern Illinois versus Central Illinois? You showed us Southern Illinois had a lot of green, Central Illinois had very little.
Yeah, sure. So for the folks online, I'm trying to rephrase the question and you can correct me. I told in the presentation that biologicals work better in a progressive system. And what the hell is a progressive system, right? Or higher yielding system, soybeans wise. And the other thing, what was different about Southern Illinois to have a higher yield and better responses to biologicals? So first answer is, what is a higher yielding system or a progressive system? You know, a good example of that would be from Brad Stewart in Yorkville, Illinois, one of our sites. We were always interested to see what in new management strategies would increase soybean yields. So higher management or higher yields are progressive systems, even though here was represented by sulfur and nitrogen fertilization and foliar protection, are those farmers that thinks of soybean, probably you guys, that think of soybean as a crop on its own and not only as a rotational crop for corn. So they invest on soybeans to have higher yields, and probably the prices of soybean now are making growers become more progressive or trying to invest in higher yielding systems for soybeans. And for the second question, there are differences on the environment. There's two things. One thing that we try to hide is Champaign, we use some university land, and that has, you know, small plots every year, so it's heavily trafficked. So we have some soil compaction there. So sometimes they're not reflect the entire region. And I might get in trouble saying this, but and the second thing was we planted earlier in Southern Illinois than the other states. We planted soybeans in mid-April, and where we were located in that year, Nashville, Illinois, it was you know, the soil was representative of the area, but the guy took care of it over the years, and we had just a better soil condition, soil health. So that's what was different about Southern Illinois. Basically, planting early the soybeans, as Rachel said, there is one thing that drives higher yields. And I would say from my own research and other talk, that just spilling some of the beans in here, for every day you delay planting from April 15 here in Illinois, you lost half a bushel of soybean yields in the end of the season. So, you know, weather-wise, not much different, although we did have some windstorms during Champaign in 2021, if I'm mistaken, during rainfill that, you know, shed some leaves and hindered the capacity to fill the pods as well. But so there is some weather plays.
Was there any return on investment on those products where you showed a yield version?
So yeah, that's a great question. Was there any return of investment? And I get this question even more frequently now that I'm with the economics department for some reason. So it's hard to estimate because those products were off-label, especially on my research. You know, they were marketed for corn. But if you get a rough estimate, by the prices of soybean right now, $15 a bushel, let's put it this way, you know, 3 bushel tendency, so 70% chance of you getting a 3 bushel response on soybeans there, you're probably going to have a return on investment, especially if you think on that free ride concept, even though we didn't test your compatibility with herbicides.
Be more continuing research on biologicals here in real life.
Yeah, that's a great question. We're gonna continue researching soybean biologicals. I just learned this morning that this soybean Science for Success with Giovanni is gonna look last year with Nemsigus' help there a little bit, and it's going to look this year again on biological seed treatment on soybeans. I know that the crop physiology lab and Connor Sill is really dedicated on investing and investigating biologicals on soybeans. And, you know, I think the broader question is, if money comes keeping in from biologicals, we're going to be still testing them. So farmer interested is a very big engagement of the money coming in for research on those products.
You got a question to your left, Victor.
Oh, yeah.
Okay, so Dr. Angelo was talking earlier that soybeans were introduced in Illinois in 1850, right? So I work with a soybean system method, and I was reading the, because soybean system method came from Japan too, right? So they're trying to find out how that nematode got to the US, right? So there were reports in the 1860s and 70s that researchers were bringing soy samples from Japan to bring inoculants, right? The result in Japan, right? So, researchers have been working on inoculants for probably over 100 years. Have you tried to look into the Illinois soils, and because we have tools to do that now, what's the population of those inoculants in our soil, right? Because if the population is already pretty high, inoculating those soils more and more, it's not really going to make a difference. So maybe you could try to correlate, these fields where you're having success inoculating the plants with the population of those inoculants in the soil. Maybe it's more of a, if that soil already has the inoculant, applying more is not going to be effective. Have you tried anything like that?
So yeah, it's a great question. I mean, I hope I had a short answer for this. But I tried in one of my trials. I partnered with, I forgot the professor's name, but we were doing nitrogenase samples from the soils. They weren't quite yet to the point to do the populations of red rhizobium, and we tried to do some fixation assays with the soybean roots as well, which we unfortunately didn't have the data because we were learning the methodology yet. So we wanted to do that, but we didn't have the capability at the time. But I totally agree with you. Probably the population here is so high, and then there's another play. When inoculants, when the soybean inoculants were introduced here in the US, the strain that they used, or that we used, was so persistent in the soil that would leave and proliferate throughout that soil that today we don't need to re-inoculate every year here in the US anymore like we do in Brazil. Even though we have the winter season, even though we freeze the soil, that bacteria is still persistent there. And I agree with you, probably in enough number of a population that inoculants wouldn't be very effective, yes.
Okay, let's thank Victor.